it looks like a really interesting collection of different people. You heard about professional education, and then you heard more about traditional school education. And I'm going to talk to you more about research. I work at Educational Testing Service. Those of you who have heard of it probably have heard of it because of association with the SAT or the GRE or the AP test, which actually is a product of the College Board that is made, administered, and scored by Educational Testing Service, or the TOEFL exam. But I work in a center at ETS called the Center for Advanced Psychometrics, which is not really affiliated with these large-scale testing programs. We're in a research division. There's about 100 research scientists at ETS who are thinking about the next generation of assessment. And I'll just tell you how I got there and here. I was originally a physicist, a theoretical particle physicist. Naturally, that led to 5 years as a sculptor and a furniture maker, and then eventually a high school teacher. Actually, one of my students went to Cooper Union, so I'm excited about that connection. And as a teacher, I became interested in education for the first time for real. Thinking about some of the topics that Ruben brought up, like how do you differentiate and scale up education and not waste time and get the most for your students. And that led to my going back to do a delayed postdoc as a physics education researcher at MIT, and I was there when the whole Mook explosion kind of happened. So Coursera was the first big, large-scale MOOC provider, and then MIT didn't want to be outdone and formed MITx, which a month later became edX. And so I was there when the edX office opened, and we had access to the very first course that was actually an MITx course in circuits and electronics. And what I do is analysis and research about the effectiveness of these things. So we publish papers. Who Does What in a massive open online course was published in the communications of the ACM, which is the Association for Computing Machinery, for those of you who know. And that was an analysis of kind of digging through the clickstream logs of the first MITx course. And then there's some other work up there that's sort of data mining of educational data. So the specific topic that I wanted to talk about today has to do with collaboration. Which is one of our kind of pillars in the Center for Advanced Psychometrics about things that we're thinking about. Collaboration is widely viewed as an important thing. It always has been, right? But it's sort of more trendy now in education to think about, now that so much information is available, what are the values that we really want to emphasize for students to learn? To learn to think critically, to be creative, to collaborate with others. And so collaboration can mean at least two kind of orthogonal types of things. One is the soft skills associated with being a good collaborator, whether that's communication or compassion or role-taking or leadership. Okay, but there's a kind of hard skills aspect to the fact that whatever it is that you do, whether it's as a professional in a business or as a scientist or an engineer, you will typically do in teams at the end of the day, so you work with other people. But the testing that happens in school happens with you by yourself, whether it's doing a pencil and paper test or whether it's doing a MOOC, right? So we wanted to think about what the consequences are for assessment, for measuring someone's ability, if what you did was take them in the context where they're actually working with other people. And that's not completely new. People have looked at evaluating teams before, but they haven't so much evaluated the individual in the team, which sort of involves simultaneously measuring them as an individual in terms of where they are and their ability and letting them function in a team. So that's the idea behind this project. We want to observe the effect size of collaboration on the measurement of the ability of the examinee in the parlance of psychometrics. So typically that's kind of complex tasks, but we wanted to make this experiment as simple as possible to establish a baseline. So something as simple as doing a math test. And then once we measure that, we would like to, of course, understand why it is whatever it is. So what is the effect size and how does it come about? So this is our scenario, essentially. We want to use OpenEdX as a laboratory to do experiments. We want to use it as a delivery device for a math test. And of course, it scores the test automatically. We're going to use math questions, we call them items, but there's questions that have already been kind of validated. They've been used by the National Assessment for Educational Progress. They've been released at this point. They're not being used anymore, so we can repurpose them. And take our sort of experimental subjects and have them take half of that test individually. So we don't get as good a measurement as we would have if they had taken the whole test. But half of it they'll do by themselves, which will give us some sense of what their math level is. And then the other half they'll do with a partner, which they'll be randomly assigned to. So sometimes you're working with somebody who's better than you, sometimes not as good as you, sometimes on the same level as you. And then they can do that collaboration either more naturalistically, like face-to-face, and we'll sort of record it, or it can be computer-mediated through chat. And if you're into social science experiments, you might think that which half of the test you do first might affect your performance on the second half. So we would counterbalance that design. So some people will do the first half individually, and some people will do the second half individually. So why did we use Open edX? This is sort of coming from me as far as ETS is concerned. ETS doesn't have an interest in Open edX other than the fact that I'm trying to get people interested in it. But it's open source, right? It's customizable. It's nimble to scale up and down. It's got lots of advanced item types. Those of you who have explored it at all with the demo courses for edX have seen that you can have kind of JavaScript simulations, a lot of really interactive item types. I know the back-end logging personally pretty well because of the work that I was doing at MIT, so I know that the event logs are very highly detailed, which makes it possible to reconstruct what happened, even if your SQL database is not good. And that's actually something that if you've ever looked at Coursera data, you'll know is different. The interoperability with other technologies, and the fact that we are in essentially the research business, we want to publish things, and if you publish something on a kind of a closed source project of yours, then nobody can really say, oh yeah, I know how they did that and I know how to reproduce it. And ultimately, the fact that it's open source means we have partners like IBL Studios and ETS, we don't actually have software development teams. When we want to do a research project that involves that, we contract with somebody, and we're contracting, in fact, with IBL Studios to do this project. So our specs were basically, we wanted a very simple, clean interface to edX that doesn't have all the overhead. We want to be able to have small private courses if we want an experiment that is online that you have to be pre-enrolled in. And then we want the ability to collaborate live through chat. So it turns out that's not part of Open edX right now. Even though you would think it would be natural for instructors in any science class or other classes to want to have students have kind of group discussions. So there are many people interested in it. And so there are development projects on it, but it's not part of the standard code base yet. We want to be able to turn it on and off as needed and kind of deploy it to do an experiment and then take it offline, but author problems. So this is essentially our kind of stack. It's in scare quotes here, but we have Open edX, and on top of that, we suggested to IBL Studios that there are some apps that have been developed that do what we want, who have been very generous to make that code available if, to incorporate it. So one of them is Mook Chat, which came out of a research group at UC Berkeley. And it's basically functions. They've managed to integrate it as an embedded app in one of the frames in edX and do some experiments where they actually had crowd workers on Amazon Mechanical Turk doing some, answering a kind of GMAT business question and then discussing it in a group and then answering again to see if they change their minds. And Bazaar, which is a product of Carolyn Rosé and collaborators at Carnegie Mellon University. And the advantage of Bazaar is that it actually has some smart natural language processing in it, so it can actually know what's happening in the conversation to a certain extent and provide adaptive feedback to a group of people if they go off subject or if somebody's being rude or whatever it is that you want to know. And Bazaar works by an LTI interface and has been recently incorporated with edX in a MOOC that was run called the DAL MOOC, which stood for Digital Analytics and Learning, I think. Okay, and we wanted to use it in Mechanical Turk. So that's it. The project was approved, and for that I want to thank Pat Killinan because he is the Senior Research Director at a different center at ETS, the Center for Academic and Workforce Readiness and Success. But they funded this research project, and we have a couple of external collaborators, one of whom is a professor at NYU, and one of whom is a psychometrician at the Department of Education. And we're now sort of just gearing up to do this project. So thank you very much.